So what do you mean by the exothermic reactions? What do you mean by the word exothermic reactions? So term exo means exit, removal. Okay, removal of something. You can simply say that there are certain types of reaction that you see that when when the reaction take place, it may be there may be change in the temperature. Like for example, there may be heat release. Like for example, you start burning carbon. So carbon is coal. So you start burning coal, you will find that coal is burning and it will giving you large amount of heat. Okay. You burn hydrogen gas. So it will gives you large amount of heat. Okay. There are certain reactions that take place in the presence of temperature. And in some reactions, like for example, in some reactions generally heat is being released, and some reactions require heat. Like for example, you have uh, calcium carbonate, CaCO2 heated, and it gives you CaO plus CO2. Or okay, or different types of reactions. Like for example, you require sunlight when you put carbon dioxide in water. This is a so when this carbon dioxide in water when you heat, it will gives you C6H12 plus okay. So this is simple. Carbon dioxide, water. Okay. When they are reacting together, they will form glucose plus carbon dioxide. So these reactions will take place of sunlight like AgBr. AgBr when kept in sunlight and kept it in sunlight will gives you Ag plus Br. So there are some reactions that take place in the presence of sunlight. There are some reactions that take place in the absence of sunlight. There are some reactions that take place in the presence of heat. There are some reactions in which heat is being released. So we will say that we have divided all the types of reaction that generally occurs into two categories. One is an exothermic reaction and the one is endothermic reaction. The reaction in which heat is being released out. That reaction is called exothermic reactions. Okay, note it down, please. Exothermic reactions. Sophia, why are you not turning on your camera? Are you there? Sophia,
Yes, sir.
turn on your camera.
Yes, sir.
Man, how are you? काफी दिनों बाद दिखाई दी. Right. Fine. Okay. Noted down. Then noted. Now let me explain you that when a reaction is taking place, okay, when a reaction is taking place, so during that time, when a reaction is taking place, so what happened here? What is happening here? Can you guess what is happening here? This is hydrogen atoms. They are broken down. They are oxygen atoms. They are broken down. Okay, the bonds are broken. older bonds are broken and new bonds are formed. New bonds are formed. The one hydrogen atoms will combine with two oxygen atoms. New bonds are formed. So whenever the new bonds are formed, energy is being released. New bonds formation results in release of energy. And older bond, breaking of bond, breaking of bond require इसको energy की जरूरत है. Okay, now if I'm asking you one thing here, that if in a business you have a business, and in that business you spend 100 rupees and you earn 120, means you sell that business or whatever you did a business of 120. Is it a profitable business or a loss business? Profitable. You spend 100, you sell it for 120, so there is a 20 rupees profit. So if you are giving, let's for example, you give in total you give 500 joule energy here to break the bonds of hydrogen and oxygen, let's suppose, in total. And let's suppose here you get 1500 joule energy is released. So what would happen? There will be a profit of 1000 joule energy. Where does this energy go? This energy will go into the environment. Are you getting my point? So in
Yes.
isothermic reaction, we can say that the energy supplied during the reaction is less than the energy released. The energy supplied is less. Sometimes you, like for example, you need to burn a matchstick. So what you do, you provide some initial heat by friction to that phosphorus. You will provide that heat by rubbing it on the matchbox. Okay. When that heat is being supplied, it will result in producing large amount of energy. So you are supplying less amount of heat and you are getting more amount. Are you getting my point? And exothermic reactions are, for example, if I'm saying that you have let about this business, you have spent 1000 rupees on a business and you earn only 800 from it. There is a loss of 200. Will you able to continue this business forever without any external help? No. That business will stop because in the first you spend 800, 1000, then you sell it for 800. Unless you get again 200 or borrow 200 from someone, you will not be able to buy the product. Like there is a product of 1000 rupees cost. 1000 rupees cost. And you sell it for 800 rupees. Okay. So there must be someone who can give you this 200 rupees for this one to borrow again this one. So they require some continuous source of income for this one to run this business in loss. But what if it is opposite? If you have borrowed it from 800 rupees and you sell it for 1000, so what the next one will be? From this 1000 again borrow this product and then keep the 200 profit in your pocket, then sell it again for 1000, then again borrow it from 800, and then this process will remain continued. So exothermic reactions are such reactions in which the energy is being released. This is a profitable. So if, like for example, you spend 500 joule in breaking of hydrogen and oxygen bonds, and the energy released during this reaction is 1500 joule in the formation of water. 1500 joule. 1500. So out of this 1500 joule, the 500 joule will go again for further reacting, and 1000 joule energy will be released in the environment. So this process will continue. Again, from this 500 joule, again the next 1500 joule energy will be released. Out of this 1500, 500 will go back again for the next molecule to react, and 1000 joule energy will be released in the environment. Then again, this process will continue. So these reactions are called spontaneous reaction. Exothermic reactions are spontaneous reaction. They once they start, they will keep on moving forward unless and until the whole fuel get consumed. Are you getting my point? They will keep on
Yes.
moving. They will keep on moving. They will never stop. Like if you start burning LPG, unless and until you stop the fuel, the LPG will keep on coming out from the cylinder and will keep on burning. Okay, you just put one spark to start the reaction. Similarly, if you have a piece of coal, you have a burning piece of coal, you start it initially burning, you give some heat, it start burning. Now this piece of coal can burn up the whole factory. Okay. So where? Because this is a spontaneous reaction. So exothermic reactions are spontaneous reaction. Once they start, they keep on moving. Got it? Got it? So please note it down. Uh, when the bond is formed, energy is released, energy is supplied. To draw this one,
I did this.
next. Do this one, please. Note it down properly. This one. The reaction in which energy supplied is during the reaction is less than the energy released is called exothermic reactions. Energy supplied during the reaction is less than energy released is called exothermic reactions. Done?
Yes, sir.
Sir, can you move to previous slide? Okay, sir.
Done. Okay. Now what we are saying here is that moving further, if I'm saying that this is a surrounding that like I'm having this bottle, okay? If I'm feeling this is hot, so Surrounding is this air and this, we can say that this bottle is a system. We will consider it system. System can be any tube, test tube, anything on which the reaction is going to take place. जिसके अंदर reaction हो रही है, that is called system. And the surrounding is anything that we have around us. Okay, like this is a system, and this is surrounding. Okay, so if we are just releasing the heat, it's a thermal reaction, the energy is being released out. Okay, so we'll say that where does heat goes? It goes into the surroundings. So when the heat goes from system to surrounding in chemistry, we consider that the energy change or enthalpy change. We call it enthalpy change. Enthalpy change during the reaction is considered to be as negative. This is the rule. That for exothermic reaction, the enthalpy change is negative. Means the value of delta H, is negative. Got it? Got it? Got it? Yes or no?
Yes, sir.
So please note it down that make this one and the energy changes. Then you will feel that surrounding get hot. Okay. Enthalpy change for exothermic is negative delta. System is anything that is under observation. I can test you anything. Done? So here,
Yes, sir.
next is now. Like for example, during a substance, during a reaction, the substance enthalpy is observed as minus 25 kilojoule. So what does it mean? That it means that it is an endothermic exothermic reaction. Minus 25 kilojoule means indicating that it is a, okay, it is an exothermic reaction. Like for example, like H2 plus O2 will gives you H2 as a release of heat. Magnesium burn in air will gives you magnesium oxide. Okay, carbons plus oxygen gives you carbon dioxide. Are you getting my point? CO plus H2 will gives you CaOH plus heat. Got it? Got it? So,
Yes, sir.
इसको लिख लो फटाफट से ये बहुत बहुत ज्यादा वेरी इंपॉर्टेंट एक्सोथर्मिक रिएक्शन तो एक लाइन calcium oxide when react with water it gives you calcium hydroxide plus heat. I'm going to show you this one.
Certain.
Exothermic reactions are spontaneous reactions that require one-time initiation. Okay, put it down. That one-time initiation means, like for example, if you means once they start, they keep on going. Does not mean, like for example, during the electrolysis of water, if you are doing electrolysis of water, you plug it off, or you turn off the switch, the reaction will stop. But here it does not. If you start the reaction, it will keep on going forever, unless and unless the reactant is extended. Reaction नहीं खत्म ना हो, तब तक चलती रहेगी. Okay. Like for example, burning of coal. If you keep on burning the coal, keep on giving the coal, then it will keep on going and going. Yes. Okay. Reaction is spontaneous reaction. Exothermic reactions are spontaneous. Spontaneous reaction means they keep on going forever. Okay. That require one-time initiation energy. While endothermic reaction, stop writing that means endothermic. Endothermic means endo entry. Word endo means entry, giving something entry. Endothermic means entry something entry. Okay, means giving something. So endothermic is therm matlab temperature means generally we give temperature, but other form of energy may also be given because the ultimate source of energy at last is heat energy. Okay, like for example, sound energy coming from the speaker get converted into heat finally. Okay, electrical energy that is being used by the fan, it is rotating the air particles and is converting. Finally, it will get converted into heat. It will magnetic energy is converted into heat. So all form of energy finally get converted into heat. Heat is an ultimate end or source of energy. If I'm talking about here is the name the endothermic reaction. So what is endothermic reaction? Endothermic last. Okay. Entry. So endothermic reactions are those reactions that are non-spontaneous. They require continuous energy. If the energy is being stopped, they stop. Let me explain. Like for example, this is a ball. Here, this is a slide. In here we kept a ball. So this ball will keep on coming downward. Why it is coming downward? Because the energy of this one is high. Energy of this ball here is high because mgh. And if when this ball comes down, it is and this is h1, it's mgh2. You know the height of this h1 is greater than h2. H1 is greater than H2, indicating that mgh1 is greater than mgh2. mgh2 indicating that potential energy 1 is greater than potential energy 2. So when the potential energy of this substance is more than the potential energy of this one, so this will automatically lose. Anything in the universe wants to come at lower energy level. Anything in the universe wants to come at lower energy level. हर एक चीज दुनिया में अपने आप हाई एनर्जी लेवल से लो एनर्जी लेवल पर अपने आप आना चाहिए without any. Like for example, I have a pen. I put this pen down. I put this pen down, it will comes automatically down. Why? Because the potential energy of this pen at this point is higher as compared to this one. But if I'm keeping this pen this one, will it goes up? No, it will not go. Why? Because the potential energy is already low here. If it is go up, we need to apply energy. Same, if the ball is kept at this end, if you want to go move it back, you have to supply the energy. Endothermic reactions condition is like this, like this. Endothermic reaction condition is like this. Like ball is kept here. You need to keep moving, keep moving. If you need to keep this moving upward, this ball, you have to keep continuously supplying energy. If you stop, either the ball will stop there or will comes backward. The same happens here that exothermic reactions are non-spontaneous. I mean they are not keep on going. They require continuous supply of energy. Okay, they require continuous supply of energy. Note it down. Done?
Yes, sir.
Now you need to understand one thing, that displacement relation is going to study displacement reactions. Like there are series of methods. Let me explain that we have a reactivity series in which the more reactive element is placed at the top. Just concentrate everyone. Look at the board. Stop writing. Like potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. Then we have copper. Then we have mercury, silver, gold, platinum. This is the reactivity series. And in this reactivity series, the most reactive is present at the top. Most reactive. And least reactive is present at the top, at the last. Least reactive. Are you getting my point? Most reactive at the top and least reactive at the last. Are you getting my point? समझ आया? अब अगर हम बात करते
Yes, sir.
हैं most reactive element displaces the less reactive element from its compound. Means like for example, if I'm having copper sulfate CuSO4, when react with zinc, it will remove it and will form ZnSO4 plus C. Are you getting the point? What I'm saying? Why it is doing so? Why zinc is more reactive than copper? Let me explain you why. Like this is sodium. Try to understand the example of sodium and potassium. Ryan, why are you looking downward? Are you using mobile phone? If I'm saying that this is the sodium, sodium has electronic configuration 281. Means it has three shells. First shell 2 electron, then second shell 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, and then last shell. Okay, 1 electron. Now the potassium it is 281. Potassium is 2881. So if I'm placing this one, that why sodium is above, potassium is above than the sodium, just because it has 4 shell and its electron 2 in this one, 1, 2, 3, 4, 5, 6, 7, 8 in this one, 1, 2, 3, 4, 5, 6, 7, 8 in this one, and this one. So this electron is far away from the, this electron is far away from the nucleus. And since this electron is nearer to the nucleus, so more energy will be required. More energy will be required to remove the electron from the outermost shell. And here less energy will be required. Less energy. Less energy. Because why? Why? Because it is at the greater distance from the nucleus. It is far away. So nucleus की जो पकड़ है इस वाले इलेक्ट्रॉन पर वो कम है. Holding capacity of nucleus, the nucleus is positive charge, this is negative charge. The holding capacity of nucleus on this electron, the outermost shell's electron is less because the distance between them is far. That's okay. But less energy will be required to remove. Less energy will be required to remove it. Now you have to keep in mind one thing. What is that thing? That is very simple. That when you are removing an electron, when you are removing an electron, the energy is being supplied. If it is less supplied, then it is more reactive than one in which more energy is being required. So we can say that potassium is more reactive than sodium. And this reactivity series that I have written here, it is only based on the one which can easily lose electron. So all of them, the potassium will lose the electron in very less amount of energy. After this one is sodium that will require more energy than potassium, but less energy than all of these. Okay, are you getting my point? You understand? in all of these elements, among all these elements, the potassium will lose its electron at very fast rates. So this reactivity series is based on the principle that the one electron which can lose its electron in a very simple amount of energy, very less amount of energy, that will be at the top. Now, since copper loses 2 of its electrons, in this one copper is Cu2 positive and SO4 minus 2, and Zn is not. Now, what is happening here is that Zn has donated 2 electrons. Now, if we move to this one and let's try to understand this one much betterly, the displacement reaction. Copper, what is happening to the copper? Copper received the 2 electron from the zinc. Actually, you see that zinc is atom. It is not carrying any charge. It is a rod. But here zinc joined with the sulfate, indicating that zinc has become Zn2 positive, and that's why it is joined with SO4. So how an element becomes Zn2 positive? How an element can become Zn2 positive? When it donates its 2 electron, Zn to Zn2 positive will only it is possible when Zn will lose 2 of its electron. It becomes Zn2. And here, if you see that this is copper, which is Cu2 positive. Cu2 positive. But it has become copper solid. Copper solid, Cu solid. So Cu2 positive to Cu solid is only possible when this 2 receive 2 electrons. This is negatively charged. The 2 negative charge will cancel the 2 positive charge. Copper solid. So what is happening here is that zinc is giving its 2 electron to the copper, and copper is receiving that 2 electrons. Now the condition is that why zinc is giving its 2 electron? Why, if you have added copper sulfate with zinc, why the reaction is going ZnSO4 plus Cu? Just because it is very simple, and I'm going to ask you. Like, you have two types of work in a day. One is that you have to sit in a room and just there will be a servant who will give you means coffee and whatever you require. You're having a cozy bed. Okay, AC is turned on. You can watch Netflix, anything that you want. Okay, so one situation is this one. Another situation is that one that you have to go outside. You have to garden the plant. Okay, you have to work. You have to clean all things. And you have to move outside. You have to go for the groceries. You have to buy the groceries. You have to come out. You have to help your mother in everything. So which lifestyle would you like to have? First one, the second one. Anyone?
First one.
First one. Everyone would like to have cozy life. No one you are having. So simply, if you want the first one, it means that you want less energy. Means because your energy in that case your energy is being required. Means you are moving for the grocery, garden work, you require large amount of energy. Okay. Simple, everything in the universe will like to shift in that portion where it is more stable, more easy. So if this reaction is having this and it when you add these two as a reactant and it is shifting to this way, वो ऐसा बन जाता है, ऐसा था लेकिन वो ऐसा बन, क्यों बना उसको क्या जरूरत थी, ऐसे ही रहता, क्योंकि ऐसा करने पर उसकी एनर्जी कम होगी, एनर्जी बिकम लेस. ऐसे अरेंजमेंट में its energy is decreased, energy become less, means the product energy is become less, product energy is less. We can say that if the zinc is donating its 2 electron to copper, copper becomes soliding like this way. From this arrangement, if it shifted to this one, why it is shifting? It is only possible if this reactant this product is having less energy. Like it is 1000 joule energy, and if it is shifted to this one, then it shifted to 700 joule energy. So it will automatically shift to this one. And 300 joule will go to the environment. Like if the ball is like placed here, the ball will come down automatically. Why the ball is coming down? Because it is at high energy level, it will again shift to this. So if zinc is displacing this copper and coming in the arrangement of ZnSO4 by its own, अपने आप आ रही है, किसी एनर्जी की जरूरत नहीं. तो इसका मतलब है कि अपने आप क्यों हुई है? Because the reactant energy is more. Reactant energy is more than product energy. and product energy. Product की energy कम है, reactant की energy कम. Okay, so it will shift. And if it is 1000, whatever the energy, if it is shifting to this way, it will release some energy. So that's why all displacement reactions are exothermic in nature. All displacement reactions are exothermic in nature. Why? Because these reactions automatically happen. So any reaction that is spontaneous means when you add it, it occurs up without any energy. It occurs by its own. That's all reaction type of reaction is called spontaneous reactions. Note it down. All displacement and double displacement reactions are exothermic in nature. Done? Done?
Yes, sir.
Now try to understand. Like for example, if I'm having AgCl, Ag when react with copper sulfate, this reaction will take. There will be no reaction. Why? Why it is not displacing? The reason behind it very simple, because it is already at lower energy level. This is already lower energy level. If you convert it to AgSO4 plus Cu, Ag2SO4 plus Cu, it means it is at high energy level. If it is okay, if it is already, the reactant is already in lower energy level, and if it's shifted to this one, if energy is increased, it will not move by its own. यहाँ पर अगर एनर्जी कम है और यहाँ पर एनर्जी ज्यादा हो रही है, ये नहीं जाएगा. तो हर एक डिस्प्लेसमेंट रिएक्शन नहीं होती. इफ इट इज Ag which is less reactive than copper यहाँ पर आता है, फिर आता है this is mercury, and then we have finally Ag. So Ag is less reactive, so it will not be able to displace it. It will not, because it has less. So already this arrangement is stable. It will not shift. Moreover, can you tell me that if you are converting gas to solid or liquid to solid, it is an exothermic process or an endothermic process? Liquid to solid, is it an exothermic or endothermic? Yes, you, Ritvika. Is it exothermic or endothermic?
Sir, it's
Liquid.
exothermic.
It is exothermic. Yes, you, Ryan. Is it exothermic or endothermic? We are converting liquid to solid. Exothermic or endothermic?
Sir, endothermic.
Endothermic. Yes, you, man.
Yes, sir.
Is it exothermic or endothermic?
Endothermic.
It is actually exothermic. Why? Because this is liquid. Liquid, when converted into solid, particle energy of liquid is more as comparison to solid. So when liquid get converted into solids, its particle will come from higher energy to lower energy, and the difference of energy will go into the environment. We kept it in the refrigerator. Why we are keeping it in the refrigerator? Why we are keeping it in the refrigerator? Just refrigerator absorb the heat of water and convert it into ice. Absorbing heat, removing heat means we are expelling out. The system is the pot. System is the pot in which water is kept, liquid water, and ice or refrigerator is surrounding. So it will absorb the heat from this vessel and convert it into. So this is. So whenever a liquid changes into solid, it is an exothermic process. Okay. समझ आया? Similarly, if I am having this one, Ba barium chloride. Barium chloride when react with sodium sulfate Na2SO4, that gives you barium sulfate plus sodium chloride. We notice that it is an aqueous state, means it is soluble. It can easily dissolve in water. It is also can dissolve in water. But here we find that barium sulfate, BaSO4. Here the barium sulfate is solid. Here the barium sulfate is solid. Indicating that something which is movable here, when they change their pattern, then will become barium will come sulfate and sodium come with chloride. So here barium sulfate become solid, indicating that the randomness of the particle here decreases. Randomness means here are moving, barium chloride particle are moving, sodium sulfate is also equal, they are also moving. But there when the pattern changes, barium make bond with sulfate, it form PPT. It becomes solid. PPT means precipitate. It becomes solid particles. And you know that solid insoluble particles. Solid particles have less energy. So here they have more energy. When they converted to this one, this is they converted at the low energy. So if it is 1000 here and it becomes 700 here, then the 300 will go into the environment, indicating that displacement reaction as well as double displacement reaction and the precipitation reaction. Precipitation means in which some insoluble substance is found. Insoluble substance means from liquid, some soluble, some insoluble means some solid particles are found. Randomness decreases. Randomness decreases. Are you getting my point? So इस precipitation reaction में energy is being decreased. यहाँ पर ये घूम रहे हैं लेकिन यहाँ पर ये solid बन गया, पकड़ they stick together. They are solid. That's why we'll say that this in this reaction we'll simply say that barium chloride is precipitation reactions are exothermic. Acid base reactions are exothermic in nature. So note it down. Reaction between acid base, dilution of acid and acid base को हम लोग neutralization reaction बोलते हैं. Neutralization reaction, dilution of acid and along with precipitation reaction. All are exothermic. All are exothermic. All are exothermic reactions. Note it down.
So done.
Done everyone? Done?
Yes.
Down. Endothermic reaction. The reaction in which energy, the reaction in which energy is supplied during the reaction. Okay, now the reaction in which energy is supplied is more than energy released. You are supplying more energy but getting less. This is kind of energy. Done? What does
Yes,
it
sir.
indicate? Like for example, if you have nitrogen, nitrogen is triply bonded. Nitrogen, when you will learn that nitrogen, there is a triple bond. Like hydrogen is single bonded, oxygen is double bonded, and there is a nitrogen. In nitrogen, the two atoms are triply bonded. When they react with oxygen, it will gives you NO2. NO2. Okay? With oxygen, it will gives you NO2. Okay. So nitrogen being triply bonded, there is a large amount of energy is being required to break this bond. Okay. So in some reaction, you supply large amount of energy in breaking the bond. And when the new bond is formed between nitrogen and oxygen, that much amount of energy is not less. You are supplying more, but when the new bonds are formed, energy is not much energy is not. So such type of reactions is called exothermic reactions. Are you getting the point? Sorry, endothermic reactions. So this is the case that at high temperature and pressure, when nitrogen is reacting with oxygen or nitrogen is reacting with hydrogen to form ammonia, large amount of energy is being required. Okay, we require large amount of energy. So have you noted up to here? Rayan, you noted? Edvika, you noted this one to here?
Yes, sir.
Okay, so Like for example, these are the reactions that are endothermic, like calcium carbonate heated, it gives you silver chloride in the presence of sunlight, formation of this one is breakdown. And
Certain.
Sir, can you move to the slide? Okay, sir. Yes.
and everyone, Jessica done.
Yes, sir, done.
Now the next one is like for example that we have written this one. That for the enthalpy change for exothermic radiation is negative and for endothermic radiation it is positive. Energy is being supplied from surrounding to the system. Means surrounding can be the wall of a glass. So when exothermic endothermic reactions occurs, so if it is occurring in a glass, then it can if it absorb the heat from the wall of the container. Wall of the container means it is cap. Heat is being removed from the wall in turn will become cold. Okay, cold because it has stolen the heat of wall. तो वॉल स्टूडेंट को रिएक्शन में वॉल की जो हीट है उसको रिएक्शन में ले लिया तो बदले में वॉल की हीट तो गई उसको तो रिएक्शन में ले लिया यूज कर लिया तो बदले में हीट वॉल कैसे हो जाएगी ठंडी सो इफ द वॉल इज गेटिंग कोल्डर then it indicate that it is an endothermic reaction. Okay, are you getting my point? So enthalpy change,
Yes, sir.
energy change for just simultaneous possible.